All right, let's start doing some basic operations with scientific notation. So here we have two numbers that want to be added, and these are both written in scientific notation. So how do we do this? Fortunately, we can look at the power over here. This is the power. And if they are the same power, which they are in this case, then our problem is just very simple. All we need to do is add our two coefficients. So let's go ahead and add our coefficients. 3.428 plus 2.941. That's going to give us 9, 6, 13. That gives us 6.369. And then our power stays the same. So that's just going to say 6.369 times 10 to the second. And then we just box that in, and that is the correct answer. Alrighty, so here we have an example where we can't add the numbers exactly how we did in the previous problem because as we can see right over here, let me see, where's the tool? Here, our exponents are different. And in order for us to be able to add them how we would normally add, we need to make sure that the exponents and the powers are the same. So how do we make sure that's the same? It's very simple. Remember how earlier in a previous video I said whenever we go left, it's a bigger, whenever we move the decimal to the left, the exponent gets bigger. And then whenever we move the decimal to the right, the exponent gets smaller. That's what I meant by positive and negative. So now that we know that, let's change this 3 over here to a 4. How do we do that? We need to move the decimal to the left once. Where's the decimal? It's right here. So let's go ahead and move it to the left one time. So now it's going to be here. And let's rewrite that. 0.238 times 10. 10 to the what? Now it's a 4 plus, and now we're going to leave this exactly how it is. 4.31 times 10 to the 4th. Now we can simply add these numbers how we were doing earlier. Put in our placeholders, 0.238 plus 4.310. Add like how I think we learned how to do this, what was it, 3rd grade? Not sure. 8, 4, 5, and 4. And now this is what we get when we add those coefficients, but now we need to bring down this power. We need to bring down these powers. So what's that going to be? That is just going to give us times 10 to the 4th. And that's it. That's all you have to do. Now let's look at a subtraction problem. So fortunately, the same rules apply. We have the same power, 10 to the 4th, 10 to the 4th. We can go ahead and subtract our coefficients. 8 minus 4 is 4. And then that's just going to be times 10 to the 4th. Now, if the powers weren't the same, then we would do the exact same thing. Just a little reminder from our old video. Let's say this was a 3. Where is our decimal? It's always here. If it's not labeled anywhere, it's always at the end of the number. What would we have to do to be able to get this 3 to become 4? We would just move this over and put in a place value and do exactly how we did in the addition problem. Alright, so now what do we do when we have to multiply some of these problems? Well, fortunately, it's really simple. All we need to do is look at our coefficients. We have a 9 and we have a 3, and we multiply them together. And you might be thinking, oh yeah, it's really easy. You have simple numbers. If you had hard like decimals or something, such as 9.312 and that 3.916, just multiply them like this, and you'll get your answer. So I'm just using easier numbers for the sake of the mental math, but if your problems aren't these easy, the steps are the exact same, so don't freak out. 9 times 3 is 27, and then this base of times 10 is going to stay the same. And what do we do with these exponents? Well, I have not made a video on rules of exponents, but hopefully we've learned them in school, and I guess I should make a video on rules of exponents So in case we don't know them yet, there's a little rule that says whenever we have a number, this number is going to be n raised to an exponent multiplied by another number raised to an exponent, the answer is going to be whatever the two numbers are together plus the addition of the exponents. So that being said, we have 27 times 10, 4 plus 2, that's 6. And I'll probably make that in red just so that it's a little more cohesive with the problem. And that's all we have to do for that. So now we have this exact same problem, except we're going to get rid of this multiplication sign, and we're going to replace it with a division sign. How are we going to be able to do this? Well, it's the exact same thing, except we're dividing. So 9 divided by 3, that's just 3, times 10. And then remember how I was saying when we're multiplying it something like this, the answer is just going to be like that. Well, when we're dividing, everything's the same except instead of adding the exponents, we're just going to subtract them. That's it. So we're going to have 3 times 10 to the second. Now, once again, how did we get that? We took our coefficient, 9 divided by 3. That gave us the 3 over here. This base of 10 stays the same. The times 10 stays the same. And then we just subtract the exponents, and that's how we got this 2. Simple. I hope that was an easy concept for you to understand.